Hi, good evening. Am I audible? Yes. Yeah. So, yeah, let's just start. If you have any doubts, just let me just type it out. If you have any doubts, just let me know so that we can go over them. Yeah. So, yeah, let us start. Just give me a second. Yeah. I hope the screen is visible. So, let's just start. So, yeah, welcome back for another session on conservation geography. So yeah, let's just go over the week 4 assignment. So yeah, the first question being which of these is the densest layer? So of the layers of atmosphere, which layer is the densest among them? So the densest layer is the troposphere because it's the layer that is much more closer to the earth, and as you go from the surface of the earth to the outer surface, uh, the the density of the layers tends to decrease because there is less gravitational force and all. So here is an example in the second question, like where the government came up with a regulation that incandescent bulbs should be replaced with LED bulbs, so that the electricity consumption and release of carbon dioxide from power plants is reduced, because incandescent bulbs generally consume a lot more uh, electricity, because they dissipate a lot of those electricity as heat, while LED lights generally don't dissipate that much energy as heat. So they're efficient in terms of converting the electricity into light. So in context of climate change, such an action would be called as. So what do you call that type of action where you are coming up with a regulation where you are saying you will not do this because this will have an impact. So you're trying to mitigate here, so that's why it comes under mitigation. And which of these is not a climate forcing for Earth? So climate forcing is something that is responsible for the change of climate. So if you look at here, plate tectonics, Earth's orbit, Sun's orbit, and Sun's strength. Apart from Sun's orbit, everything has a contribution to how climate is on the Earth at an instant. So going ahead, which of these contains the most water vapor and aerosols? Which of these four layers? Troposphere, stratosphere, mesosphere, and thermosphere. Obviously, it's troposphere because that's where a lot of our that's the densest, and there's a layer where a lot of the clouds are, and most of the water vapor tends to be around. And yeah, which of these is true about Coriolis effect? Sorry. Yeah. So if you remember the Coriolis effect, it is the effect that is basically the curving of the path of the object or fluids due to Earth rotation, because Earth rotates in a certain direction. When you try wants to move in a straight line, or when a fluid wants to move in a straight line, it can't. It kinds of changes turns into certain direction. So that is called Coriolis effect, and the force that is being acted upon that fluid is Coriolis force. So which of these statements is true? It is maximum at pole and zero at equator. It is zero at poles, maximum at equator. Or in the northern hemisphere, it deflects winds towards left. In southern hemisphere, it deflects winds towards right. So it is a maximum at pole and 0 at the equator, the effect of the Coriolis force. So from the surface of Earth to upwards, which of these is the correct sequence of atmospheric layers? So it's simple. The lowermost strata is troposphere, and the outermost is exosphere, right? And the middle is mesosphere. So obviously we have just 1 and 3, and then up on top of troposphere stratosphere. So that's the order it is. So it's just straightforward. And the next one being the ability of a system to adjust to climate change, including climate variability and extremes, to moderate potential damages, to take advantages of opportunities, or to cope with the consequences is a definition of. So what does it kind of say? So it's a definition of adaptive capacity. So it talks about how much can we adapt to climate change if you're talking about here climate change. So flights of jet planes typically occur in which of these layers? So they generally occur, if you can see from this infographic, they generally occur in stratosphere, the commercial jet planes. And going ahead, noctilucent clouds are present in which layer? So here the noctilucent roughly translates to night shining clouds. So this is which layer do we get to see them? So these are formed mostly in the mesosphere. It's like the middle of all the 5 layers. So the way these are formed is really interesting, is because when ice particles actually freeze in the mesosphere, when the water vapor actually freezes in the mesosphere, it kinds of, when light actually hits those particles and reflects, it looks like a cloud like appearance. So and these are actually visible during the night because of there is hardly any light coming from the sun at that surf area. So these reflections are much more visible. And interestingly enough, when a lot of the space shuttles that launches into the space, so they release tremendous amount of water vapor as a reaction of, as a result of that reaction, the hydrogen and oxygen combustion. And that water vapor also can lead to formation of this noctilucent clouds in that layer. So this is how they tend to look like. Pretty beautiful. And ionosphere is a part of which layer? Ionosphere is a part of the thermosphere. It's where most of this bombardment of ions from the outer space happen actually, and that's where these beautiful auroras are formed. Yeah. So sorry, yeah, that's all with the week 4 assignment questions. So if you have any doubts or anything with these, let me know. We can deal with that. I think most of them are straightforward enough, but still if you have any confusions we can deal with that. If not, we'll I will wait for a minute or so, and then we can move ahead and discuss one of those uh, clarifications one of you have requested in the previous session. So yeah, so we're discussing about climate change mitigation and adaptation. So their effects, and then now, so since we know that climate change is going to happen unless until we do so and so, or we know some of those effects are not are unavoidable, so you tend to adapt. So thus the word itself give away what that word means. Mitigation here, with, with respect to climate change, mitigation can be defined roughly as, you try to put up interventions where you try to reduce the sources of carbon, or enhance the sinks of carbon. Here, reducing the source means lesser usage of fossil fuels, or all other things that are related to carbon. That kind of actually increases the climate change, or enhance the sinks of carbon. Enhance the sinks, either you can have multiple ways you can enhance them, be it afforestation, which is one way, or the carbon capture and storage systems, where you try to capture the carbon from the air and then you pump it down into huge storage reservoirs. Or other way, you can reuse the carbon, where you have net zero carbon release, but you're using that carbon that is already there in the environment and releasing the same amount, but the amount that is newly added into the atmosphere kind is zero. So that is what net zero is. So there are multiple ways you can try to mitigate the effects of climate change. Since carbon is a major player, we talk mostly with respect to carbon. While adaptation, on the other hand, is kind of an adjustment or a response to what is expected from climate change effects. For instance, a lot of these coastal regions, are going to, according to projections, that the sea levels are going to rise. A lot of these coastal areas are going to go underwater. So they are trying to put up structures, build up structures, so that people uh, don't lose their homes or their livelihood. So they're trying to adapt to those scenarios. Like for instance, in Venice, which is, you might have heard of, watched it in movies, which is a city that is almost very close to sea surface, or roughly it has a lot of water channels around. So they had these beautiful systems installed around the city, so that during high tide or low high tide, not much, or storm surge, not much water enters the city, because these structures can actually block some of those waves or some of the water. So that's some of the way we respond, so that all is not lost. So that is broadly what is climate adaptation means. Mitigation, how do we mitigate? When you just we are talking about mostly about reducing emissions, be it from factories, or be it from travel, or be it just generation of energy itself, using you know different other forms of energy, renewable sources, or non-carbon sourced energy forms, can itself be a form of mitigation. And creating sinks is what we already talked about. So so there are different ways when you talk about adaptation, right? So so you can classify them majorly into anticipatory versus reactive. So if you look at this table, uh, you can look at it from both ways, right? You can have a classification like, you have a long term prep, this is going to happen, and then you plan for that, and then you have a strategy, you have an adaptation for that. So that is an anticipatory category, while reactive is like, it has happened, now you are trying to get back from that thing. So those examples fall under reactive category. We'll go over those examples in a bit. While that it can be classified in terms of system you are trying to do, whether it's a natural system, how natural systems are going to adapt, or nature in general, versus human systems, how we humans are going to adapt. And there is also public property, or public way of dealing with it, and simultaneously private, or in terms of individual level, right? So how nature, anticipatory, it's nothing, there's nothing we can do here. So there is nothing because it's more of a reactive system. That's how it happens mostly in nature. There might be few exemplary cases, but so there can be, for instance, if you talk about plants, there can be changes in length of growing season or changes in ecosystem composition owing to climate change. Like for instance, if you remember the escalator to extinction, so that's something that happens as an effect of climate change happening, right? It's more of a reactive kind of uh, response. By and similarly wetland migration, so movement of wetlands because there is, or drying up of wetlands because there is no water or there is a lot of water. While you come to human mediated things, early warning systems, or we have these systems prepared, like if you see this in this pattern happening, we might be having a cyclone or there might be something else. So, or like the example that I was discussing about Venice, right, where first protecting the city from the storm surge or high tide, very high. So yeah, so you anticipate that this is going to happen, so you build up these structures. So you did build up structures to kind of prevent lot of effect from that thing. So which this is all public related, or you might provide incentives for relocation or movement of people from one place to another place, to relocate from one place to another, so that you are not directly affected, but you will be affected in the future, but we are trying to help you, give you a head start so that you are left with nothing when that thing actually happens. While in private sector, private way, there can be a number of things. You can make your housing, for if you talk about buildings, housing conditions to extreme weather events. If you are from a region that is going to have a lot of rain, or you might want to make houses that can withstand that rain or floods, so on. Or you can invest in insuring your place or your life, or even your source of income, so that you're not affected, or this is going to happen, so let's better be prepared. So this is advanced in preparatory, but these are things that happen. So what you are going to do? So compensatory payments or subsidies, for instance, if you remember about the tragedies that have unfolded in the past 2 months because of this, this uh, huge landslide that happened because of this high amount of rainfall. Let be either it in the Himalayas in Himachal, or be it in Western Ghats in Kerala. So there have been a lot of compensatory payments or plans to relocate some of those, or rebuild some of those uh, villages, so that they can actually go back to at least some sort of life, what they used to have. So that is what the government's planning to do, right? So that's one way of you doing, you provide subsidies or you provide compensatory payments, or your preparation of protective structures, or when it comes to individual level, so you may make a lot of changes here. uh, like for instance, if your fields are getting washed away, you plan to next time protect your fields, or maybe not put your agriculture fields in those areas where they are prone to lot of water inundation or so. So this is some of the way how how adaptations, different type of adaptation can happen. And then yeah, this is the different way of classifying, and there are lot n number of examples that can fit into each of this category, and then you can break this up into n number of ways also. But I felt this is the main categories that has been used even by IPCC that we were discussing last time. So I just took up this example from this article, and then yeah, I was discussing this. uh, Hope this was, hope you could grasp some of this thing, because this was something that someone wanted to know about this different type of adaptation categories. Hope is that clear? Yes. Cool. In that case, let's go ahead. Yes. Yeah, thanks for the confirmation. Let's go ahead and yeah, just talk about briefly about this cycle because we'll lot of us know what is the water cycle about, what it is. So it's basically the circulation of water on Earth. Most of it, goes in form of evaporation from the ocean, evaporates, forms clouds, and then when it hits land or when it hits a cooler surface, when cooler airs, it actually comes down in the form of precipitation. The precipitation can be snow, water, hail, or any other forms. And then the major chunk of this evaporation happens from ocean because oceans are the largest open water bodies that you get to see, but there's a lot of evaporation that happens from the surface itself, from land surface, like ponds, lakes, rivers, from soil itself. And even we respire, so our even when we breathe out or other organisms breathe out, they respire a lot of water vapor, so that also goes up. And the transpiration or the where vegetation kinds of pump out water, it also goes out and then again goes back into the cycle. And then simultaneously, and yeah, simultaneously the lot of water can also go underground, and then they can be stored in those deep reservoirs, or they end up meeting one of those major water bodies that kinds of come out onto the surface. And in some locations, the deep water percolations, if this water percolates into these deeper rocks that are impermeable, or these crevices, they might stay there for much more longer time before being circulated. And yeah, that's a major chunk of that water cycle. But this precipitation and evaporation uh, is not even across the earth. So if you look at this plot where latitude versus evaporation, so there is an increase around 60-degree latitude, and then again a decrease between just after 30 degrees is a sharp dip, and then around the equator it just increases much more higher. And then the evaporation is higher around those areas but lower around the equator, right? This is an interesting phenomena because of the way wind patterns happen, and then that's why there is a dip in precipitation around 20 to 30 degrees latitude. And then if you look at uh, later on, if you go back and just look at the world map of where most of those deserts are, they tend to be around these regions, where around these latitudes where there is a relatively lower precipitation, majorly owing to these wind patterns that happens. And yeah, there are different names of wind patterns, like the trade winds. There are easterlies, westerlies, based on how they form or the path they take. So that's an interesting phenomena you should maybe look out later on, where all the locations of deserts are. They tend to be around these areas. And yeah, oceans. There is nothing more new to add to number of oceans and where all they are. But there are a lot of other structures that actually are in present in the oceans. Like there are these ridges, like the mid Atlantic ridge where you spoke earlier, and there are these plateaus, there are these trenches, and yeah, the Marina Trench, as you can see on this right corner in the Pacific Ocean, is one of the deepest point in the ocean. It's greater than 10 kilometers in length, right? And then the five major oceans: Atlantic, Pacific, Indian, Southern Arctic, or the Southern Ocean is sometimes divided into multiple oceans also, depending on the way you want to classify. So if you look at the surface areas and volumes of oceans, this is an interesting infographic. If you want to explore, you can check it from Britannica's webpage. Yeah, I just wanted to show this area they are in. So the largest is the Pacific Ocean, and then the Atlantic, followed by Indian, Southern, and the Arctic. Arctic being the smallest ocean of all. And these are not actual true boundaries. There are no true boundary that defines the Indian versus Southern or Pacific versus Atlantic. They're just rough boundaries we draw, but when you look at most of these oceans, there is actually intermixing of water that happens. That's how a lot of these things, a lot of these circulations of nutrients and water currents happen. But on surface, you might see, they might have come across some videos where where two oceans actually meet, or there might be slight change in water color because of the different components of the water, or different amount of depositions from the land that has come into the water. But more or less there is a lot of intermixing of these oceans, the ocean water that happens. And then if you take a cross section of uh, how it looks, the different things, that how it looks when once you start going beyond the beach, after which under the water. So the landmass or the continent kind of continues till some point, and then it starts dropping off, and the point till it continues in the water is called continental shelf, after the coast till the drop off point. And that continental shelf gives rise to the continental slope, where where the drop off actually starts. And then there is this slight rise, continental rise, and then the abyssal plain is just like deep abyss, is never ending, kind of roughly translates to never ending depths. And then it's a complete plains, uh, not really plain, but it is a vast, uh, more or less flatter area, but there are a lot of structures that are present on there. And this continental shelf, the length of the continental shelf can vary from place to place, and they might stretch even to hundreds of thousands of kilometers, or just few kilometers, just from the shore. So when you talk about when you talk about a lot of fishing grounds, a lot of people tend to go, a lot of these fishing boats or vessels tend to go close to this edge of the continental shelf, where because that's where this deep sea water that are rich in nutrients tends to rise up, and then that's where a lot of fish congregate. And then if there is a lot of food, a lot of fish, then it's a good catch. And sometimes when these rivers that actually drains up into the ocean actually cuts deep into the continental shelf, it leads to a formation of a submarine canyon. Canyon is basically a deep gorge like structure that you get to see. uh, and then since they're submerged, I think that's why the name submarine. And then there are these structures that come up called seamounts, which we'll go slightly ahead and then discuss slightly later. But yeah, so the continental margin you call till the end of the continental rise is what you call the boundary of the continent. And till the boundary of the continental shelf, till the end of the continental shelf, this the rights of the country is decided as the economic rights. Yeah, it's just another photograph of how those different structures are, like the shoreline versus continental shore slope, rise and abyssal plain. And then the ocean is also, it's not a uniform thing. It's divided into different zones. So the zone till the right light reaches, right? Uh, it's or where the photosynthetic amount of light reaches is called littoral zone. And then because and beyond which, even although the light reaches, there is hardly any photosynthetic wavelengths available. So beyond which it's called pelagic. And then yeah, the photic is the depth till which you get to see the light being able to penetrate much better. And after littoral, it's sublittoral, and then it's all benthic, bathyal, abyssal, hardal, and then the pelagic in the water. You can classify it as epipelagic, mesopelagic, bathypelagic, and abyssipelagic. So different depths that based on classified based on different depths. And beyond 200 meters or little less than 200 meters, you hardly get any light. So if you look at some of those beautiful fishes groups like anglerfish, and there are a lot of squids, they tend to have bioluminescence for for preying or for escaping predators, so that they can survive in these bathypelagic or abyssal pelagic zones. And some have even lost the sense of the ability to sense light, or they have very reduced lights eyes, so that since there is hardly any light for you to detect, so why invest in having eyes? Let's just make up with good sense of smell. That's how, let's spot food using the sense of smell. That's how they do. So yeah, there are different organisms that are related located in across different regions of this. And there are very few organisms that migrates from one zone to the other zone, because the pressure differences are so huge, or the factors that affect the species are so huge. Generally they are adapted to certain regions. And then if you tend to take some of those organisms out of these deep sea zones to another zone, they kind of, what you see are this entirely disfigured organisms. Like there's this images of species called blobfish, which is actually a deep water fish. I think bathypelagic zone fish. Once you take it out, because it uses Acumstat to surviving such huge amount of pressure. Once you take it out, it just bursts out like and then it looks entirely disfigured out of its natural habitat. Yeah. So, and then as we are talking about density, there is a differences in temperatures also as you go from the top to the bottom. So the and then there is a layer of water. The layer, the top layer is going to be warm, because that's where the sun rays or the heat from the sun actually comes and heats it up. So that's where the epipelagic zone mostly, which is kind of heats up in the day and much more warmer. But as you go down deep down into other zones, the bathypelagic and abyssal, there is hardly any light coming or any heat coming, so the water tends to be cold. But there's a transition zone, or the layer, that is present between these warmer surface waters and then cooler deeper waters. And then it is called, this layer is called thermocline. It's not only for, this term is not only used for oceans but also used for lakes also, where there is a drastic change in temperature of the water, and there's a transition that happens between this darker, sorry, uh, warmer and then colder waters. So that layer you call as thermocline. Similarly, there are other layers, other type of layers. If you look at density layer is called pycnocline. So the density is of water is actually 1025 grams per centimeter cube at the surface, but after 1000 meters it just sticks around 1028 grams per centimeter. So the density increases and then kinds of maintain it constant. If you look at salinity, it kind of actually drops down around 500 meters, and again there is an increase, and then it kind of sticks around that same value. So this transition layer is called halocline if you talk about salinity, and in case of temperature it's called thermocline. Thermo is temperature, cline is lines, or basically the line that depicts the change in temperature in water. That's the easy way you can think of remembering it, right? Yeah, just give me a sec. Sorry, yeah. Yeah, that is just simple thermocline, halocline, and pycnocline. And then there are other lot of underwater structures that are present in oceans. So one such structure is seamount. Uh, do any of you know what is a seamount? Any guesses? Yes, yeah, you're right. So these are underwater mountains. This as simple as you can see. If you look at this elevation profile data of a seamount, so it's 5 - 5000 because uh, zero is our sea surface level. If you remember, Everest is somewhere around 8800 something meters. This so if you go, it's minus. So the sea surface is minus 5000, and then the peak, the red part here that you're seeing is less than. It's around, let's say 14 minus 1400. So as you can see from the picture itself, it looks like a mountain. So these are underwater mountains. They can be active volcanoes also, but they are under the ocean itself. They are not projecting out of the surface, and they can be formed along ridges, like you were talking about earlier, or you said here, or they can be formed dispersed also. But most of them tend to be around the at the junction of tectonic plates. So here is a infographic of what we are seeing is a seamount. If it comes out of the water, we call it as a sea volcano, or simply volcano also. And yeah, there are different structures which will come slowly. Atoll versus Guyot, right? So yeah, so the seamount projected outward and formed into a volcanic island, right? That's how most of these volcanic islands have formed. The earlier stages it was uh, simple seamount, but later on became a volcano, right? After that, after it's due to a lot of other processes that happens, uh, the island might start sinking, right? And then it might lead to formation of a guyot. Guyot, in the cross section, this is how it looks like. It's a seamount. The earliest stage is a seamount. Post a volcanic stage, once it goes down into the ocean, it will be called a guyot, right? Instead of collapsing because of erosion or other factors, uh, if there is a if the island starts sinking, but there is still there is a slight landmass that projects out of the surface, but there is a ring of corals that kind of formed around because the depths are shallow. because of this the volcanic rock itself. You call it a barrier reef, right? There is central island, central volcano in the middle, and it is surrounded by uh, a coral reef. You call it a barrier reef. So the reef is acting kind of as a barrier. But after this formation, if the island sinks down further, or it is eroded at the top and it goes under the water, and there is ring of corals that is actually outside, and then there is a lagoon inside, we call that an atoll. And then, yeah, seamount is the one of those earlier structures, right? So this is the different structures that you get to see on the abyssal plain mostly. And then for a volcanic island to rise from the abyssal plain, it has to be, a lot more taller, in terms of elevation, because sometimes the ocean, as we were talking earlier, the marine trench is greater than 10,000, 10 kilometers deep, but most of the ocean is not that deep, right? And yeah, this is just a formation. This is just another way, another infographic on how these atolls are formed. We had this volcanic island earlier, and then it has sunk down, but the outer surface has deposition of this sand, or and then coral starts growing up, and this is how it looks from the top around. That's a barrier reef. And then volcanic island sinks further, goes beyond below the sea surface, you will have an atoll, a lagoon. And this is how they look like, the atolls. As you can see, it just used to be, it should be a round of coral reefs with few trees and vegetation. And then what exists to be a volcanic island in the center is no longer there. And then these areas are pretty rich in biodiversity, in marine biodiversity, because they are formed in the middle of the oceans. And then, yeah, but most of these atolls can be formed only in the tropical and subtropical waters. The reason is simple, because most of the corals are tropical species, they like warm waters. And if it's not coral formed, it's not an atoll by the definition of it. So since most of these corals are tropical species and they like warm water, these atolls are found mostly around in warm waters. And there are a lot of islands that are just group of atolls itself. Okay, uh, when we're talking about climate change and all, this is a term that tends to come up a lot. It's called albedo effect. So any guesses on what it is, or what do you think it is? Okay, so the term albedo effect talks about the amount of light that is reflected by body or surface. Here, when we talk about albedo effect, we are referring to the amount of light that is majorly reflected by eyes here, mostly in the caps, both uh, the polar caps, Arctic or Antarctic, and even Himalayas. So, if you know, yes, the reflective of Earth's surface, yeah, you can say that also. So basically, when a lot of light, the light, yeah. So since a lot of light that comes from the sun, most of the light is reflected by these white caps, right? These polar caps that are mostly covered in snow or ice, just ice, because they are essentially white. They tend to reflect a lot of light. But with climate change and all, what happens is these ices are melting, these polar caps are kind of shrinking, and then water, which is not really as good reflector as ice, it tends to absorb a lot of light, and then it warms up the water much more faster, and then it kinds of acts in a positive feedback loop where increase in one leads to a decrease in one another, and then decrease in another means an increase in further of that thing. So as the water gets warmer and warmer, the ice melts much more faster, and there is very little ice, so there is very little light that is getting reflected off the surface, and a lot of light energy that is being retained within the earth's surface. So it kind of goes on in the loop. So yeah, it is a really an important way to understand the way that polar caps are actually uh, putting down the temperatures of earth. But because of this climate change, this is kind of not at what it used to be. Yeah. And then upwelling is basically the movement of water, because the ocean is now just calm, even the underwater. It's basically upwelling is deeper, colder, nutrient rich water, the bringing up of to the surface. It's called upwelling. And this is where a lot of, because it's nutrient rich, a lot of organisms tends to be there, and then they are close to the surface, and then there's a huge set of you know the food chain kinds of uh, adds up there, and then a lot of organisms tend to gather around that area. And these upwellings are generally, if you look at this figure that we were talking earlier, generally happens mostly around, because the water currents come around here and then hits the continental slope, and then they rise along the continental slope till the continental shelf. And then because of this reason, there are a lot of species that tend to congregate around continental shelf. And when a lot of people go around to watch birds, especially these pelagic birds or the birds that live on the high seas like albatrosses, there are some birds called uh, petrels, storm petrels. There are a lot of other birds. Okay, so they tend to congregate around this continental shelf because there are a lot of nutrients coming, and there's a lot of fish coming, or or their prey coming around to that surface, and then that's a rich feeding grounds. So they go there. So people also tends to go around to the edge of the continental shelf to look out in search of these birds, and then a lot of times you do get to see them. So that is upwelling, where a lot of nutrients tends to come up to the surface. And then there are these gyres. So gyres are nothing but uh, ocean currents that have been circulating around, and then these go around all these oceans and then across the globe, so that there is a lot of mixing of water happens around. So if you look uh, at these colored ones, the darker, so these are warmer currents, and then the bluish ones are the colder currents. So around the poles, these are much more colder, and then around the tropical subtropical region, they are much more warmer. But the warmer currents do actually travel far north and south, and then there is a lot of intermixing that happens, right? Most of the time, uh, it doesn't exceed zero point 0.8 knots. The transformation is a little difficult, but yeah. So they are not that fast, but roughly, yeah, roughly 6 feet per hour. So which is very slow movement, but it's a very consistent movement of water. And they kind of, if you remember the Coriolis force, uh, they kind of tends to form circles because of different forces around. And then these different currents that form these circular patches are called gyres, right? But these are really important in, uh, dispersing the heat, or mixing up of oceans, and also in the dispersal of plastics, right? There's this famous Great Pacific Garbage Patch, which you might have heard or come across. So it's nothing but all the plastic that we have put up in ocean, washed up into, because of this ocean current, washed up into this one single area, North Pacific region, and formed up this Great Pacific Garbage Patch. There, it's not a single patch. It's there multiple. It's a eastern patch, western patch, and then subtropical convergence. There are multiple ways it is in. So it's major. It's present between Hawaii and California, the major part. Because of these ocean currents, everything is getting clumped up, and then they just keep circulating here and here. So yeah, that's how it looks like. And then in the North Atlantic gyre, and then this is not the, it's not this, uh, Pacific, but all other gyres also accumulating plastic, but major producers of plastic, or wherever they dump, they just are sticking around their neighbors. These are circulating. So major producers that have been dumping them, they're just sticking close to them. Yeah. Uh, Hi. Can you hear me? Yeah. Uh, Hi. Hope you can hear me. Right? Sorry for the inconvenience. Internet is bad here. So let me just share my screen again. Yes. Yeah. I hope the screen is visible now. Yes. So I was just talking about gyres and the Great Pacific Garbage Patch. And then there are other garbage patches also, but the Great Pacific Garbage Patch is the major one. So yeah, then these currents are really important. They bring up nutrient rich water from one region to another, warmer waters to one region to another, and then they actually cool down much of these regions. And then even some of these currents, like these warmer currents that actually go up into the Arctic Ocean, is actually responsible for faster melting of those polar caps also, because the water is much warmer than what it is around that place. So they play a huge role. And since we're talking about just the plastic, there are a lot of impacts on wildlife, or especially the marine organisms, or the organs that are dependent on marine oceans. The one major problem is through ingestion. Other is through entanglement. Entanglement, as you might have heard or watched a lot of sea turtles, is one of those species that get entangled a lot. And then these guys have to regularly come up and then breathe air, because they can't, get oxygen from water. They have lungs, so they have to come out. So if they are entangled in these discarded ghost nets, and then they're just doomed unless until someone tries to cut them loose from the net. Because if they when they exhaust, when there is no more oxygen, they can get up and breathe. It's done. The other thing is ingestion. So a lot of these plastics break down eventually because of the action of wind, water, and then sun and other elements, and then they break down to smaller particles. So a lot of these species might actually mistake for food, or when they are consuming food, they might accidentally consume and then they ingest, and these ingested particles can interfere with their bodily processes, and then they can die. And this has become a huge problem, because recently people started finding microplastics everywhere, and even in the base, even in a lot of foods that we consume, because the plastics have gone up in the food chain, and also they have been getting in at different stages into the food chain itself. So yeah, they are present in everywhere. And then the different type of uh, plastics that are kind of actually formed, if you look at different classifications. Polyethylene, the basically plastic bags, is the one of the major form of plastic, microplastics, that you see in oceans. Polypropylene, form usually used in making bottles, caps, ropes. Polystyrene, the plastic utensils like cups, spoons, and all. Polyester, polyurethane, PET, polyethylene tetraphthalate, which is used in bottles like Coke and all. So some of them are not easily degradable. Some of them break down pretty much faster, and then linger on in the oceans for a lot of time. And then, yeah, there are a lot of uh, proactive things that are being taken, steps to being taken to actually remove a lot of these plastics. But we're at a point that, in the future we might actually had to live along with plastics in the food we eat, or uh, because we have put up a lot of plastics, this wonder material that used to be called when it was invented. But it's there everywhere, even in the remotest areas, in Antarctica to in the Himalayas. There's plastic. That's a sad reality. But yeah, and we humans are responsible for them, and at different processes just do their job of dispersing. So yeah, and that's all for that's all I have today. So if you have anything, let me know. I would be happy to answer, because that's all I wanted to talk about for today. Okay, great. Okay. Uh, any more topics that you want me to cover in the next session? I would be happy to take, or else, yeah, I will just touch on some of those topics that are being discussed. Uh, if no suggestions or any questions or doubts, yeah, yeah. Oh, sure, sure, no problem. But yeah, if you have any doubts, drop a message, or you can ask them in the next session itself, where I will be happy to deal with them. So yeah, that's all I have. So anybody who had recently joined, I was asking if you guys have any doubts so that I can help you get over them. Because yeah, the topics that I want to deal today were kind of finished touching upon them. Okay, in that case, if no one has any doubts or anything, we'll call it a day. And yeah, that should be the end of today's session. Thank you for joining. Yeah, you can exit. I will wait if anybody wants to join and ask anything. Yeah, thank you. Okay, guys. Sure, that should be the end because doesn't seem any of you have any doubts and nobody is asking anything. So yeah, that should be the end of today's session. Thank you for joining. See you next week. Bye. Yeah, thank you.